Hi, this is Miss Rodriguez, and I will be going over chi-square today. In class, we worked on M&Ms, and for this example, I'm going to be working with some data based on Skittles. So follow along, pause, and work on your calculations and check your work. So I hope you enjoy. So this is a chi-square test example using Skittle distribution. A chi-square can be used for category data, which for example is number of Skittles per each color in a bag. The critical value or level of significance is 0.05, and this is what we're going to be using. So a hypothesis is an educated guess based on our prior knowledge. So the null hypothesis is observed that data that fits our prior expectations. So it's denoted H sub O, and for our example, it's going to be the Skittles are randomly distributed evenly. So if I expect there to be the same number of each color of Skittles in my bag. And the other is an alternative hypothesis. An observed data that does not fit our prior expectations. So for this one, it's H sub A, and this would be the Skittles are not distributed evenly. So there's an unequal amount of a certain type of Skittle. So now we're going to talk about our observed data. Our observed data is a number of Skittles per color. So this is the actual frequency of the colors of Skittles in my bag. So the actual numbers of the amount of green Skittles, yellow, purple, red, and orange. The expected data is the expected frequency of Skittles. So if I wanted them to be all the same, then if they're supposed to be all the equal amount, then it would be that value. So let's look at our chart here. So in my bag, when I opened it, I separated all the different colors, and I noticed that there were 20 green, 7 yellow, 8 purple, 13 red, and 19 orange, for a total of 67 Skittles. Now, how do I get the expected number of Skittles? Well, if I expect the equal amounts for all colors, then that means if there's 67 Skittles and there's 5 colors, the 67 Skittles should be divided equally into 5 different colors. So 67 divided by 5, and I plug this into my calculator, I get 13.4. So now this is my expected distribution. So this is my expected frequency, and it should be the same for all of my colors of Skittles. So I completed my chart of the expected frequencies, or the number of Skittles, if everything was equal. So now let's calculate our chi-square. Our chi-square is equal to the summation of our observed frequency minus our expected frequency squared over our expected frequencies. Now the summation means that you're going to add up all your components for each category. So let's begin. My first frequency is green. So let me get the appropriate color. So for green, it's 20. minus our 13.4 frequency, expected frequency, over our expected frequency. And the top should be squared. Now, for our yellow, let's see if you can see this. Is 7 minus our expected frequency, quantity squared, over 13.4 our expected frequency. Now we're going to continue this trend for purple. So 8 is our observed frequency for the amount of purple Skittles minus our expected frequency. So I have finished the rest of the frequencies, as you can see. Now we can go ahead and calculate this. 20 minus 13.4 is 6.6. Quantity squared over 13.4. Plus 7 minus 13.4 is negative 6.4. So we can continue this. So now I put in the rest of the information for our equation. If we plug this into our calculator, we should get 10.835. Now, we're going to hold off on doing anything with that. We're going to get back to it. We're going to talk about the degrees of freedom. The degrees of freedom, denoted dF, is equal to the number of categories k minus 1. So the number of categories was 5 because there were 5 colors: green, yellow, purple, red, and orange. So the degrees of freedom is 5 minus 1, which is 4. Now remember our critical value? That was 0.5. So now let's look at our probability less than critical value chart. So we're going to find our degrees of freedom. So here I found my degree of freedom, 4. I'm going to highlight across. Notice that this chart has 9.95. Well, this is our 0.05 to make the 100%. So here is our critical value. And in this case, we have a 9.488 p value. So now, our chi-squared was equal to 10.835. According to this, we can see that the chi lies right of our p-value. As the observed value gets more different from the expected value, the chi-square value will get larger. In our case, our chi-square is larger than our p-value, so the number of each flavor become more different from the 67 expected frequency. Since our chi-square statistic is right of the p-value or larger than the p-value, then there is a probability that the Skittle factory is not producing equal numbers of each color or flavor. At this point, we say that the observed results are significantly different from the expected results, and then we can reject our null hypothesis. So we reject that the Skittles are evenly distributed during packaging.